Okay, but looks like we'll go ahead and get started here. Good morning. Welcome to Boundary Systems webinar series for Creo Parametric 4.0. Today we're going to be discussing additive manufacturing, and today's October 25th, 2017. So let's jump into this. So real quickly, just an introduction and overview of Creo Parametric 4.0's additive manufacturing add-on module here. And for the agenda, I'm going to run through a quick overview of Boundary Systems and myself. And then I will give you a quick demonstration here on the additive manufacturing module. We'll go through a product overview, and then I'll jump into a technical demonstration. And at the end, I'll answer any questions anybody may have along the way. So feel free over in our chat box here for the dashboard for your GoToWebinar. We have the ability to ask questions, so feel free. Anybody's got any questions, go right ahead and queue them up. We'll get those answered here at the end. If you got any other questions, feel free to just jump right in there, and we'll be monitoring that through the meeting here. Also, over on the right-hand side in your application there, you should have two handouts. I've added an infographic for additive manufacturing, just give you a little background on additive manufacturing, and then I also gave you a data sheet on the extension for additive manufacturing. So let's jump into this. So my name is Aaron Spicer with Boundary Systems. I'm a technical specialist for Boundary Systems. I have 20 years of experience with PTC products, includes training, consulting, and implementation. I have a pretty good extensive background in additive manufacturing as well. So next up here, a little about Boundary Systems. So Boundary Systems is a technology leader. We're partners with the including companies PTC, Solid Thinking, eTraj, ZWCAD, and other technology companies. We're number 16 in the fastest growing private companies in Cleveland. Capabilities include product lifecycle management, data management, CAD design and consulting, simulation, and product development. Over on the right-hand side here, you can see several of our customers that are listed here. And if we don't see your name up there, we'd like to definitely get you added to this list here and help you guys out. So let's jump into the next slide. A little more about Boundary Systems. Industry awards, we're an Inc. 5000 listed company, Weatherhead 100 company as well. And some of our major accreditations, we're Windchill Certified Implementer, PTC Preferred Services Provider, and a PTC Certified Training Partner. And I'd like to announce that we've just recently become a PTC Gold Partner as well for software solutions for PTC. So congratulations to the Boundary Systems team. And a few more of our partners here that we're listing. Next up here, technical questions. We have a support team that is more than willing to help you out at any chance we can here. So you can reach out to the support team, support@boundarysys.com. Any one of the 9 available applications engineers can reach out and give you a hand with any of your technical issues that you may have with the software. And if you're looking for sales information, feel free to shoot an email to sales@boundarysys.com, and somebody will be prompt in returning that information and getting back to you as soon as possible here. You can also visit our website, support.boundarysys.com, and you can log a call there. And again, the entire team gets that email, and somebody will follow up with you and help you out with any technical issues you may have with the software. Okay, so let's talk a little bit about additive manufacturing, or 3D printing, as most of us remember the terminology. Also, roll back a little bit. Rapid prototyping was another famous terminology that was used with it. We're going to cover 4 areas this morning. We're going to cover lattices, lattice optimization, tray assembly, and nesting capabilities. So just a little bit of a roadmap for PTC's Creo additive manufacturing. You can see here, got several different things over on the left-hand side that are readily available today in the software as it's being delivered to you. So you can see we've got AMF, high order facets, output only on that portion, but we do have the ability to do so. Tray assembly, printability checking, parts and assemblies. So printed parts, we can have a watertight, minimal walls, hole capping, sharp edges, and support. Lattice support structures here, lattices and design of lattices. 2.5D and 3D lattices are supported in Creo Parametric 4.0 additive manufacturing. We also have 3D printer connectivity available for Stratasys and a few other machines as well, and more are coming along here as we move forward with PTC and Creo's development team. 3D nesting capabilities are available to us, and we also have the ability with Creo, since we are a several different packages in one here. We have the ability that we can analyze and optimize our design structures for our lattices within the Creo software. So we're going to demonstrate that for you today, and let's take a look at that. So some forward thinking here. They're going to move into NC inspection and mold, some splitting of large parts and the capabilities to do so within the 3D printing software capabilities. Again, the AMF software, multi-ingraded materials capabilities, and supporting structure optimization moving forward as well. It's pretty exciting stuff that they've got coming. So a little bit on the 3D printer's connectivity. We have printer selections. It selects a 3D printer from the list. Again, I'm going to show you this in the demonstration portion of the material here. The ability to select different materials for that 3D system or that 3D printer system that you are currently using. Finish, allowing you to set up a glossy or a matte finish if the machine allows for it, and the materials that you're going to be printing with allow for that as well. And then finally, we have the ability for calculating your build. So it calculates the required amount of build and support materials and displays the outcome in a graphics window for you. So PTC is broadening the ecosystem with this. You're going to have bi-directional exchange of information between PTC, Creo, and the 3D printers. So we can optimize these and make sure that we're running good parts each time as we go through the system. Again, the end goal here is to make sure that we're staying within one ecosystem. We don't like having the ability of going out to multiple systems, data getting lost along the way here. So we want to be able to follow through and be able to keep it all within the Creo environment or Creo ecosystem, if you will. So next up here. Lattices. So the ability for our lattice structures here, 2.5D and 3D and conformal lattice structure capabilities. They're single features, parametric control over all aspects of the lattice structure, and you get a full B-rep geometry capabilities with that as well. So just a couple images here of some of the lattice structures as they're developed into these parts here. You can see these are some metal parts that were printed, and then the lattice structures within the internal portions here. Frame of a bike, we're loosening or tightening this up with lattice structures again in the design of that part here. Again, the lattice structures are the ability to take your shape, still keep and conform to the overall design portion of that part, and still make sure that it works with the environment that you're going to be putting in it. But the end goal is to make the part lightweight and still capable and being rigid along the way as well. So from a standpoint of optimizing our designs here, you can take a look at a quick example here. We've got a part that was originally designed, the material was titanium. You can see the yield stress, the ultimate stress, and the mass of the part right now is at a 6.09 kilograms. So running it through simulation results, you get a von Mises of 36.23 MPa and a max displacement of 0.044 millimeters. So in the initial stages here, when we've just laid out the initial lattice design, no optimization involved with this, we're able to reach a yield stress here of 139.96, ultimate stress of 219.94, and we were able to get the mass down here, you can see 3.48 kilograms, with a reduction of around 42.83% of the overall size from the original design. Simulation results come back, and we can see here that we have a MPa in our von Mises of 61.77 and a displacement of 0.073, so a little bit higher than what we had originally. So I'm going to take a look at the next results here. And this is our optimized design. So again, the material is still titanium. Same stresses and the same ultimate and yield stresses are provided here. The mass, though, is down to 3.28 kilograms with a reduction of 46.21%. And you can see the von Mises here has jumped up dramatically. So we're at 104.22 MPa with a max displacement of 0.086 millimeter. So again, your initial design of a mass of 6.02, you get that down to 3.28 kilograms. And so we've optimized that design at a 46.21% reduction. So we'll go into the example there. I'm going to show that in the technical demonstration. We're going to walk through a part, and I'm going to optimize that design and show you some of the lattice structure creation tools. Next up, we're going to show you the tray assembly. So a tray here is a repository for your parts and assemblies to be printed, assign the materials, and store other attributes and parameters into those parts. So again, this is one other interface that we can eliminate you having to go out to another system in order to do this. And we're working with companies such as 3D Systems and Stratasys to ensure that our print beds and everything that is required in these softwares are set up properly and work synchronously with your 3D printer systems. Another portion here that we're looking at in Creo 4 is the capabilities for nesting. So nesting is a set of objects of graduated size that can be stacked together, each fitting within the one immediately larger part here. So it's a method to optimize the tray portions here. So you can see in the example here, we have all of our parts spread out here, optimizing those with the nesting capability. We're stacking those internally inside one another, and you're ready to go. So let's take a look at the demonstration portion of the software. I'm going to jump into Creo here and get started. All right, so additive manufacturing is the process of building an object with one thin layer of material at a time. Definition is simple, but the 3D printing process is not. So there's a lot involved with this. And most importantly, when we're taking a look at parts like this, you can see the part that we have here right now, a pretty thick part. And again, I'll just jump up on the screen here. And let's just take a quick section through the part, and you can see that we have a design here, very thick on the material side. And if your concern is making sure that you're not using too much material here, and we've optimized that, then this is going to be a great addition for you to take a look at here for this. So we're going to start off with this part, and you can see here through the center I've got this this recessed area. Let's go ahead and modify this. Let's edit its definition. And we are using Creo's 4.0 for this. So some of the capabilities are a little bit different if you haven't seen 4.0. Definitely take a look at some of our webinars that we have around what's new in the capabilities. Most importantly, they're working to work us within the model tree here and not have to, or within the model and not have to be all over the dashboard area. So let's take a look at this option here. We're going to take this feature and I'm going to cut it all the way through the part. So I am going to go up to the dashboard here. Let's just go ahead and remove the material all the way through the part. And we're left with the design that's been hollowed out like this. Well, again, this isn't going to work for our design here, and we're not optimizing anything yet, but I need to apply a lattice structure in this. Once we get the lattice structure, then we'll start working at optimizations on this. So the next thing we're going to do, I'm going to come up here to the Model tab, go into my engineering group, and I'm going to select on this capability here for lattice. This is our lattice tool. And you can see in the dashboard here, we have several different items that we can select from, a few different tabs that we can work through. Each changing as we change different items in this. You'll see some of those modifications on the screen here as we walk through this demonstration. But let's start off with the first example here. I'm going to go ahead and get a view orientation. Take a look at the part here. And what we're going to do is we're going to place the lattice structure in this area here. So let's start off with, let's gather the surfaces. I'm going to pick up intent surfaces here. Then I'm going to need to close and gap this here. So that'll be the area that we're going to engage and put this material into. Also want to change the size of this here, and I'm going to use a half scale here to reduce the overall size. And let's take a look with the preview glasses. Okay, so we've got our first preview here of the lattice structure, and you can see inside the part. These are solid geometry features that we have in here. It's clipped it off at the top here and cut off any geometry necessary at the height of that to ensure that those are, at the right height and not sticking out past the part any. All right, let's resume this one here. And next up, let's take a look at a couple different styles of the lattice structures that are available to us. So let's go over here, and I'm going to start by selecting on the cell type. I'm going to change my cell shape here. So I'm at square right now. Let's change that to triangular. All right, we have our triangular shape here. And I'm also going to uncheck a few items here. So let's get rid of the inner horizontal beams. And you can see some of this geometry start to disappear as I'm clicking on some of these items. And then we also want to check the box here for remove any dangling beams. So we don't want anything outside of the lattice structure areas. We don't want anything dangling. Let's go ahead and get rid of any of that geometry. And that should clear it up a little bit. Let's take a look at what the resulting geometry is here now. Right, again, you can see your structures are built up inside here. It took a few minutes to generate that, but again, it's processing all of that information here. And as you can see, there's a lot of geometry that's being generated and created during this process here. So let's also change a few other items. Let's go back here and let's resume. And instead of using the 3D, let's take a look at the 2.5D design. And we're also going to change the Z direction here, or the direction for this feature. Let's change it to a Y direction. Let's go to pick the cell tab. And let's change the shape here. We had the triangle. Let's change this and go back to a square shape. And let's take a look at that geometry. All right, once again, we've got that material in here with that lattice structure with those capabilities that we had set up for that. All right, let's take a look at a few more. So the regular pattern is what we have set up for right now for putting this in here. Let's take a look at creating a quasi radial. All right, so you can see the shape here. And again, let's take a preview inside the geometry, see what it looks like. And you can see that herringbone effect that you got going on in here, the quasi radial effect, sorry about that, going on in that model. And then let's check on how the cells are placed again. So let's go back here, resume. Let's change that quasi radial. Let's go back to the regular shape. And let's change the design here again. Let's go to the cells. Instead of using the square, let's go to the hexagon shape here. And then let's take a look at the preview of that geometry. Once again, that's spaced out. We have the geometry inside here again. A few more items to check. Let's go back here, resume this one. And we also want to take a look at adding the ability to add a drain hole as well. So you can see as we do that, adds the drain holes here. Now you have capabilities. We can modify a lot of this information in here. So this is all sizable. We can change and modify these as we see fit for the design. All right, so let's get rid of this one here. Go back to the geometry. And let's make a few more modifications. Check that out. Go back to our 3D design here. And let's go back to our shape. Change that again. Let's go back to a square. And now that we have that in there, let's go ahead and let's modify the beam for that structure. So we're going to go in the beam settings here. We're going to modify a few items in this. So let's take a look at the cross-section size. We got a value of 0.05. Let's change that to 0.03. And let's also change the diameter of the ball diameter here. So we're at 0.15 right now. Let's change that to 0.13. All right, and as you can see, as I'm updating that, this information is changing on the geometry over here on the preview example that we have. So now let's take a look at the geometry once we've created it here. Again, it's generating that. But you can see as we've done this here, we've got this pretty thin, so that's probably not going to work out too well. We also have this ability that we can change, and we can have a variable depth starting from one end of the part and sweeping down to work with the sections and the cross sections here. As we're applying different forces to this part, we'll be able to maintain the strength and rigidity of this part as we go through it. So let's make a quick modification to this, if you will. So I'm going to go back here, and I'm going to pick the play button. I'm going to come over here to my model tree, and I'm going to unhide an item and show that item in here. I'm going to set my Z direction here. Let's change this back to a Z direction for this. And then we need to pick the density tab. And I'm going to change the density of the material here. So we're going to double click on a new set. And then I've got some items here that I can modify and change in here. Let's change some values real quick. Let's set the first thing here, the distance. Change that from 50. Let's put it at a value of 2. And then for the reference cross-section size, let's modify that. The value is set at 10 right now. Let's crank that way down. We're going to select on 0.08. Set that value here. Now, we need something to reference for this. So we're going to select this wall that we've just shown here, this thin wall surface. Select that for the geometry selection process here. And now once I have that selected, that's got in my references dialog box here, I'm going to go ahead and just hide that again. We won't be needing that anymore. And let's take a look, preview the geometry. And you can see from front to back here, right in the center, we've got the thicker parts, and as it walks away from it, it begins to thin out a little bit to the right side, and then again to the left side where it's thinning all the way down here on that material section portion. Let's jump into this real quick. I'm going to go over to the Analysis tab and take a look at the mass properties on this. And when we originally started this, I apologize, I should have pulled that up and taken a quick look here, but the overall size of this part was set at a 0.264 for the pounds when it was originally started out. So that was the original or the initial design analysis for that with the mass properties. Let's take a look now that we've got the lattice structure, see what that looks like now. And you can see now we're at a 0.183 for our mass in that part. So we've reduced that quite a bit here. But the thing we're not sure of during this process was the depth that we had created here. And on the geometry that we have presented on the screen here was ensuring that that was optimized for this design. Yeah, we've created a lattice structure, we've removed material, got that weight way down, but is it going to work for us in the example where it needs to as we take that out and start demoing this part, making sure it works? Well, let's make one more quick change. I'm going to go inside here. Let's go ahead and cancel out of this and go back to my lattice structures. I'm going to resume this. And I'm going to make this a little lightweight. Instead of having the full geometry for the lattice structures here, pull this down. I'm going to select on Simplified. With that simplified connection now in place, I'm going to go ahead and check this off. And you can see here, I have a simple wireframe simplified version of that lattice structure on the inside of that. So that'll make it easier as we take this over and we analyze this part and we do a design optimization, which we're going to do over in Creo Simulate. So we're going to go ahead and jump into that portion of the demonstration now. So we've got that representation now set. And one more thing before we do that, in order to do our analysis on that over in Creo Simulate, we're going to need to add a material to this. So let's take a look at our materials and assign a material to this part. We're going to select the part out of the model tree here. I'm going to right click on it. And now in Creo 4, you've got this ability, we can edit materials right from the model tree. So let's take a look at that functionality. Edit materials, a little bit different than what we've used to seeing in previous builds of Creo here. But now you can see here we have standard materials, Granta design, and then you have the legacy materials. So we still have some of the old materials still available to us, but the new standard materials, Granta design, is definitely worth looking into. Quite a good selection of materials here. So let's select down through here. Let's go to a plastics. And let's start with this one here. We're going to set it to a peak material. I'm going to select on peak. As you can see, all of the information has already been supplied to us. Sample materials from Granta design. Definitely worth checking them out if you want to have a very robust collection of materials here and some valuable information as you go through your design process and design analysis. Check out grantadesign.com/PTC for more information. Or you can reach out to Boundary Systems as well, and we can help you as you're investigating that as a solution for you as well. All right, so we've assigned the material here. And you can see here the peak material is now down in the bottom, and it's highlighting there. I'm going to go ahead and select OK here. Now you'll notice over in our model tree, we now have underneath the name of our part, now that we've edited a material and added that material to this, we have this little option underneath here. We've got a node we can expand, and we can see the different materials that are now available for this portion. This is really nice if you've got the ability here that you want to analyze a part, not sure of the material that you want to go through. You can set up several different styles here of materials, and then as you run through each one of your analysis, you can just revert back, take a look at the materials and change those out as needed, run back into your simulation, and then begin your process over again there for your optimizations. Okay, so we've got the material assigned here. Now let's take a look at the Creo Simulate environment. We're going to come over here to Applications, and let's go ahead and activate Simulate. You know, a little warning that pops up here. Now you can see we've got a preview here of the geometry that's on the inside here, and because we went to that simplified version of that lattice structure, you now see you've got the blue beams here that are representing the material that was in there. And again, it's going past that a little bit, but as you recall, in that design process, that geometry was all trimmed out. It's filling in the geometry here as we go through the optimization, just to get all the material that's necessary for that. Then it'll take those designs and it'll condense them down as necessary. So let's set up a few displacement constraints for this. Let's go to our displacement view here. And we're going to apply some working conditions to this model here. So let's take a look at our displacements. And we need to pick up some geometry here. So let's go ahead, selecting our geometry to select from here. We're going to select the hole here. And then let's gather the other hole down at the bottom here. I have all four of those now set. So I'll go ahead and select OK. So it applies the constraint to those features in there. Now let's go ahead and let's apply a force or a moment to this as well. Let's go back to our start view. And we need to apply the load. We're going to apply the load on the teeth here. And I'm going to apply some values. So let's take a look at this X value. Put a value of 100 in here. And then for my Y value, I'm going to apply a negative 50 value. And then let's set the units there to be newtons. We've got that set. And we're ready to go here. So let's select OK. And let's run an analysis on this. So let's go up here and create an analysis to run. Let's go up here, File, New Static. Got some information. Let's fill this in real quick. All right, so we'll leave all the other settings here. Just select OK. All right, we have this. Let's pick that and let's go ahead and let's start that run. And we're not going to run that interactive. Let's just go ahead and run it. Take a few minutes to run here on the analysis. And you can see it's already completed here. We've got that analysis run. Let's go ahead and close this. And let's take a look at the review results here first before we do that. Let's go ahead and select the review results. And we'll say OK and show here. All right, you can see we've got all three of the views that pop up on the screen here, and we're taking a look at the von Mises stresses. This is in an animation mode here, and then the displacement magnitude for this as well. So we've got our numbers over here that we're going to be taking a look at, and this is what we're going to analyze for our optimization process. So we've got this done here. Let's click in the stress animation portion here. And let's pick measure. So as we pull up the measures here, we get this extra window that pops up. And let's select on the max stress VM here. So we're going to scroll down through here. There's our max stress VM. Once we have that, let's go ahead and let's add an annotation to the model here. We'll create our annotation here. So we've got our max stress VM, 2.79, and it's e to the 6 here on the stresses for that part. Let's select in this max displacement window. All right, so we select in that next. Again, let's take another measurement. This time, let's take a look at the max displacement magnitude here. So we're going to go ahead and select on that. And let's go ahead and, again, create the annotations so we can see where we're at on this part here for this design process as we go through the optimization portion now. So let's go ahead and close this. And you can, again, we've got our results here. Close this window out. We won't need that one. And you can see quick analysis on our displacements and our stresses on this part. All right, so let's go ahead and close this window. Close out the simulation portion, and let's go back to our design side here. Now let's optimize our design. So, first step in doing this, let's go up here. Again, we're going to create another study here, but this time we're going to go for the optimization. So we're going to go ahead and select on the new optimization design study. And again, let's give it a unique name here so we can keep track of this. All right, and we need to set up some design limits for this. So I'm going to go ahead and I'm going to select OK there. And let's set up some of the limits that we're going to need to make this happen here. So for the design limits, we're going to start over here and start over by selecting on this. And we're going to select the max stress VM. That's going to be the first thing we're going to target on this one. So let's scroll through here. There's our max stress VM. And then we need to set the value for this one as well. So we've got this. Stress VM. Back out here, make sure we get that right. Yeah, change that number here. So my max stress VM, I'm going to put a value of 2.1 E6 for that value. And that should be at the inch pounds here. Let's add another column. We're also going to set up the max displacement magnitude. So both of those items that we were tracking in that first test here, Those are going to be our targets that we're going to shoot for in this one. All right, so our displacement magnitude that we're going to set up for this one, we're going to use a value of 0.124. That's what we're going to shoot for. Hit enter there. We got the 2.1, e to the 6 on this one as well. Let's make sure we got that. Okay, so we have both of those in there. And let's check for variables. Let's make a variable item here. So I'm going to pick on my view. Let's move this over here, get my view orientation set properly. And we're going to select on the O2 optimization portion of this. And we're going to select one of the lattices here. So I select the geometry here. Come on. Lost my window. That geometry. Let's try that again. Sorry about that. Back to my optimization. Set these up again real quick. Right, we got that. Okay, here. That value in again. Let's add in more. Again, let's set that value there. All right, let's try this one more time. And now I've got my preview here. And we're going to modify some of the numbers here. So we're going to select on the, let's find the value here that we want to select on. First one I'm going to use here, cross-section size, make sure I got the right one. And I'm looking for there it is. Make sure I got the right one here. So set the first one here. This is going to be for our minimum, our min and max ranges on this one. We're also going to select on just one more time. Select that lattice structure again. And we're also going to select on the value here. Make some modifications. I got one more we're going to select from as well. Select this one here, and we're going to select datum 1. Zoom out, there's a value here I need to modify and change, so I've got that range as well. So these are going to be the variables that we're going to control with this model. And let's make some quick changes. Let's set up the initials, the variables here. So start with this one here, and let's go to a minimum of 1.8, and then we'll set the maximum value to 4.5. For the ball diameter that we had there, 0.02, and let's go up to 0.05 on that size, 0.03. And then let's go for the values here on this one. Let's set those values. We got the 0.13 to begin with. We'll go 0.12. And then we're also going to set a max value here, and let's go to a max of 0.15. All right, so we have all of our controlled variables here, what we want to control and optimize. So let's go ahead and select OK. Now we have our analysis here. Let's go ahead and run it. Takes a few minutes to run this optimization again. And again, I've got a little more memory in my computer, so these running a little bit faster, 32 gigabytes on my machine. So this analysis is should run a little bit quicker than you'd normally see on most engineering systems. Most people are running 16 gigabytes of memory on those. I encourage you to have as much as you can if at all possible, especially if you're doing stress tests like this. Give you a few more minutes here. It should be wrapping up. Should be just about there. It'll take a little bit longer than thought here. Make sure it worked out okay. Right, there's our test results. We can go ahead and analyze those, take a look at our optimizations. And we've got a nice little chart here we can take a look at and review. And you can see here, we started off the high end here for our total mass of the part. And then the optimization process, we've dramatically reduced that through these optimizations. It took 6 different passes to go through that part in order to get the optimized design size here. So let's go ahead and we're going to pick the close simulate results here. And not save those results right now. And then we're going to take a look at our compare our stress results. So we're going to pick on the next button here. We're going to review the results. And let's start off in the first one here. We're going to call this one up model. This is going to be our stress, the title, and then we're going to select OK and show. Right click on this one, and we're going to take a look at the model max on this one. And we're going to copy this one. So I'm going to come over here, I'm going to select on copy. And we're going to select open here. And we're going to select on that original model here for the static analysis. Static analysis selected, and then the next thing that we're going to change on this, select OK and show. Right click again, take a look at model max on this one as well. All right. So as you can see here, in the stress results window, we're comparing the original design to the new design. We can see how the system has changed the lattices and achieved the optimal maximum stress and the minimum weight for this part. So you can see there's been a dramatic change in that design style here. We had some high stresses in the back side of it. Now that we've got it optimized here, we've eliminated some of those stresses. All right. So next up, let's take a look at the displacement on this one. Let's double click on this one to modify it. And now let's call this one op model, and we're going to rename this one displacement. We're going to select OK and show here. Once again, let's right click on this and let's show the model max. Double click into this one as well. And again, optimize design. Take a look at the displacement. OK and show. Again, there's our optimized design. Let's right click on this one and show the model max as well. Okay. So we've run through the optimization portion of that, and in the displacement windows, you can see the maximum displacement and the new design is smaller with those changes in that optimization process. All right. So that takes care of that portion of the demonstration. I'm going to go ahead and close this window here. Close that out. Again, I'm done with the analysis portion, so I'm going to close this out as well. Start orientation, and let's exit out of the Creo Simulate portion. And let's go back. Now that we've got the optimized design, let's go ahead and modify the representation of that lattice and take a look at that. So I'll go back over the model tree here. edit the definition, and let's go back. Instead of the simplify, let's use the full geometry. Check this off to complete it. Now that we've got the optimized model, let's take a look at that. So we're going to go back into simulate portion. And I'm going to change my view orientation here. And go back to my analysis and studies here. Select on info. And then we're going to go ahead and select on from the info tab. We're going to look at the optimize history. And we can take a look at the shapes here and what's been modified. Just select X to not review. Now that we've got that all ready to go and the optimization is ready, let's go back here. I missed one here, one of the checks. Optimize history. And this is the one I want to go ahead and check this one off. Now that I've got the analysis all done and run here and my optimization is in place, I'm going to go ahead and it's asking me here, do I want to leave the model at the optimized shape? Yes, we do. We want to go ahead and take that optimized shape. Go ahead and check this off. Regenerates the model for you. And now our design has been optimized to that new analysis once we've gone through that process, set everything properly. All right. And again, one last thing here. Let's just take a look at our analysis. So I'm going to go ahead and I'm going to close out of simulate. We're done with the simulation portion of that. And now let's take a look and review our analysis on that part. So our mass properties here. Go back and preview those. And you can see we reduced that part size here. We're down to 0.178. And originally when we first started off here, I told you we were on 0.265 to begin the process. So we've reduced that quite a bit here on the size of that part. And again, we've conformed to the rigidity and made the part a lot lighter in the process with this material selection and then the lattice structures that we put in place. All right, so great. We've got the part all analyzed, optimized, ready to go. We just need to get it off to the 3D printer. So let's show you the next portion of the demonstration. And it's going to be the 3D printing side. So let's go over here and let's take a look at that. All right, so pretty simple process to get to it. You're just going to go over to File, and you're going to hover over Print. And now within the print capabilities here, you're going to see Prepare for 3D Printing. So let's go ahead and kick this off, take a look. And again, for demonstration purposes, we're set up here with several different types of machines and materials to select from. We're just going to take a quick look here and select on the printer types. You can see I have different styles here that are selected. I'm going to go ahead and just take this default tool room, set that one up. You can see the bed size has changed on that. Now it's all ready to go. And let's go ahead and let's pick on the auto position and let Creo work its magic here to get the part into place. You see it turns the part up here, gets that part into the bed, and lays that flat into that bed there for you. And again, not impeding the bed here, so we've got the part right at depth of what it needs to be. And once we have that there, we can select Arrange on Tray if we need to. Now we've got that part in and ready to go. So let's do a quick printability and validation. So we'll select this. And then we're going to go ahead and select the model that's in the tray here. And what this is going to do for us is allow us to run, and we can take a look at the minimum wall thicknesses and any tolerances that we have on this part. We're just going to go ahead and leave the display here the way it is and just select Compute. Taking a few minutes, it's running through. And it just shows you the validation of the part and any thin wall conditions that you might have on it. It highlights that for you. You get a 3D note here. So you can quickly just take a look and evaluate anything you may need to. But right now, for the intents purposes of this demo, we're going to go ahead and just leave this here and close it. But again, very nice technique in there to make sure that you've got a part that is going to print out properly for you. All right. Just make sure everything's going okay over here. All right. So the next thing, let's pattern the part inside of the model. So we're going to still use Creo, the capabilities inside of Creo to do this with it. So I'm going to go ahead and select the part out of the model tree. And now I've got the capabilities here, and again, with the new mini bar toolbar that pops up with it, anytime we select on anything, we get this little mini toolbar that pops up. And one of the options that's available within this one here, I can go ahead and I can pattern this. So let's select pattern. And I'm going to set the type instead of fill. Let's go to direction. And we're going to select the surface as shown here. Let's go here. And in the first direction here, let's set the number to 4. And let's change the spacing. I want to change the spacing to 40. All right, and I'm going to do this in 2 directions. So I'm going to stack these up on top of each other as well. So let's go to a second direction. And I'll pick the plane here for my second direction. Let's set the number in that direction. We're going to go to 3. And again, my spacing. Let's modify the spacing, go to 50. All right. So I have all that done here. Let's go ahead and check this off. And again, our parts are in there, but again, they're kind of overlaying one another. Not going to work out too well, so let's just use the software here to take care of that. We're going to pick the auto position and then arrange on the tray. Now you can see here, we have the parts evenly spaced out, ready to go, and not interfering with one another. Optimized design here, so we've got the printed parts stacked up nicely in this process. So we've got the ability to also add multiple models. So let's add another model line to this one. So we're going to go ahead and select the assemble. I'm going to select on this other part that I have in my folder. And once again, I'm going to go ahead and use the, let's just use the checkbox here to complete it. And let's auto position and arrange on the tray. You can see we have our part in here. One more time with the patterning here. So let's select that part one more time here. We got that. Let's right click and let's go ahead and pattern that. Change it again in the direction. Number of 4 in the first direction here. Let's go 4. And let's change the spacing once again. Check that off. Our parts are in there. And again, let's go back to the auto position and arrange on the tray. We have those parts stacked up nicely inside here. And we're ready to go. So next, let's take a look at the display for the support materials in this as well. So the next thing that we're going to do, let's come over here. Got my tray with the selections here. Go through one more time. Do the compute. And again, there's a few errors in there on that. But again, just enough there to bring the warning up to speed here. We can see what's going on. So let's go ahead and close this. All right, so once we have this ready, we're ready to go ahead and export this out and send it off to the printer. So what we're going to do is just simply go up to the top here, select on File, Save As, and now inside here I'm going to save an STL of this. So let's just go ahead to the STL. We've got our tray 1 that we've selected and set up, and we can select OK. Now the STL is all set up and modified, ready to go, and we're ready to hit the print button and head it off to the printer and get that thing printed off and take a look at our parts after we've optimized them. So that ends the demonstration portion of Creo's additive manufacturing. We'll go ahead and close the window here and go back up to the display here and open up the floor here. Anybody have any questions for the demonstration that we did today? I'll give it a few minutes here. If you want to go over to the dashboard area for the GoToWebinar, you can take a look. There's a questions section. Go ahead and select in that, and you can type in any questions you may have for me. Otherwise, I'd like to thank you for your time today and appreciate you stopping by for this demonstration. We will be having this available up on our YouTube channel, so Boundary Systems up on YouTube. Take a look at us there. Many different webinars that we have there, and again, this one will be available tomorrow if you'd like to go back and take a look at the demonstration that we presented for you today. So thank you for your time. Appreciate it. Have a great day. We look forward to working with you here at Boundary Systems.